myself because we're already late. Just a few information may be useful for you listening today. So I'm the co-founder and CTO of Bauplan, which is an early-stage startup doing data infrastructure for AI, which I guess is very relevant for the conference. Fun fact about me, I don't know how many of you have built data pipelines in your life before. How many people have built data pipelines? OK, so quite a few people here. So if I take the median of this imaginary distribution, I build pipelines in a scruffier and probably shittier way than all of you at garage scale. And then I build pipelines at IPO scale. And that makes me an expert because I made all the possible mistakes that somebody can actually make when building data pipelines on the cloud. Bauplan is a Pythonic data platform for data and AI. It's built on basically two main ideas. One is people care about business results. People care about getting stuff done. People don't care about managing infrastructure. And B, everything should be code. So if you're used to data platforms that are like point-and-click oriented, a bit bulky, a bit hard and slow to deploy, Bauplan feels like a library. So there's no PhD required, no data engineering expertise. You can just tell any of your normal software developer to learn in a few hours, and you're good to go. Bauplan is based on S3, on object storage, whatever object storage you prefer to. So S3 here is a placeholder for any object storage, or blob storage, or whatever you want. And this is very relevant for what we're going to discuss today. The message that I want to come across today is actually a message of hope. We saw many people in the talks during the day. They were like struggling to put AI into production. Many people that are having difficulty going from prototype to actual business impact. And what I'm here to say is that most of the things you need to actually be good at this, you already have them. And on one side is AI model, and on the other side is basically basic cloud infrastructure. I'm old enough to remember, I think Chip mentioned this in the first talk today, I'm old enough to remember when AI, let's call it old AI, like as old as I am, was about getting data from somewhere and then building models. And building models has a few components, which I summarize here in training and survey. Of course, a bit more nuanced than that. But the idea, again, going back to Chip talk today, is that you actually have to have specialized skills, a lot of specialized people, and a lot of time and resources to go from data and models to actually produce old AI. Thanks God, none of this is true anymore, right? As generative AI wave coming at us, we find that we still need data. We're going to talk about that extensively. But that we now substitute the entire model part with code. And code right now is mostly APIs, right? You don't need to train your model. You can just ask somebody else's model to do the job for you. You don't even need to serve your model because you can just call an API. So instead of a specialized army of PhD and people that understand the entirety of the tool chain of ML, normal software engineer can put stuff to production. Of course, that may raise other questions like reliability, scalability, safety, but it's not a bottleneck in skill set that we had before. And what code means today? Code mostly means Python. For better or worse, Python is, as people say, Python is the second best language at everything. So for better or worse, Python has become the de facto standards in AI and data, and now is actually the most used language on the entire GitHub universe. So if we continue with my equation, so sorry for the algebraic nature of this talk. So GenAI is now data, and then we can replace code with Python, which is basically synonymous with code these days. What's the issue? Is that running Python actually sucks. I'm sure many people are familiar with the bug called "it works on my computer," which is a very, very annoying thing that happens in organization when you do something that it actually works on your computer, but then things in production need to work on somebody else's computer, which is typically owned by Jeff Bezos. Okay? And so in the process of moving from the computer that you own to the computer that Jeff Bezos owns, a lot of shit actually can go wrong. And in fact, that's why working with Python in the cloud is actually very, very miserable. Well, let's keep it at that. So we have Python, which sucks for many reasons, but at least it's good at ours. And then how do we replace data? Like what are we going to do with the data variable in my fantastic PhD level equation that I designed? And for most use cases, data today literally means files in the cloud. So this is an example. This is a real example. I didn't make it up. So this is a real AWS example on SageMaker and Airflow, if you know what these words mean. If not, it's not really important. But what you can see here is that the way in which people pre-process data and read data is by literally hard-coding a file. Okay. That file, again, sits on S3, which, if you don't know what it is, you can basically conceptualize a very, very large hard drive that is also owned by Jeff Bezos. Okay? And then your pipeline basically starts by reading data from here, then you're going to do some magic with Python, and then you're going to save the result somewhere else. What's the problem with S3? So S3 is very durable, meaning that once you save something in S3, it's basically stored forever. Okay, you can assume that basically stored forever, or at least is as safe as anywhere else in the world you actually can save it. But there are two big issues, and one is performance and the other one is versioning. So the problem with performance is that when you run your AI pipelines based on files, you do what's here on the left, right? So you're reading files somewhere in S3, and then you have another operation that basically, in this case, subset the columns, right? And you don't need to be a PhD in databases to understand that logically, this is kind of a stupid way of going about reading your data, with all due respect for the people that did the repo in the first place, okay? So what you really want is what you do on the right. Like, since I'm reading a table, let's say that I just need a column, C and C2 and C3, and I just want a column when some conditions is true, that C1 is equal J. What in an ideal world I would want to do is not read the entire file and then check the columns. What an ideal world I would want to do is read directly the subset of the file that I really, really need. Of course, this toy example with 3 rows and 3 columns doesn't really matter, but imagine this being one of your AI pipelines reading hundreds of millions of rows. The difference between reading 2 or 3 columns may be massive, both in terms of efficiency and in terms of cost. So problem number one with S3, the Jeff Bezos hard disk, is that it's actually not very good if you take it at face value for performance. The second thing that you need if you do AI is the possibility of being wrong, okay? The fact of the matter is that the easiest way to generate business value with AI pipelines is making as many mistakes as you can in the shortest possible amount of time in a safe way, okay? And how do you make mistakes in a safe way? We can borrow a concept that we all learn when we learn how to code in the first place, right? Git. So when you want to do something that is like a feature or something new that you want to develop, when you want to debug something in something else you don't do it on the main version of your code, you do it on a branch. So what you would like to have for your data set is the exact same component that you have for the Git, but for your data. We call it Git for data. So in this example, for example, you have a main branch, which is where your data is in, and then for each of the models that you may want to try, let's say GPT, Gemini, Claude, you open a branch in your lake and you create different versions of the data set that you need enriched by this AI model, okay? This version lives at the same time in your data lake. They're addressable, meaning you can check each one of them irrespective of the other, but they do not bother production. You see, production is the blue line there, is completely unaffected. That allows you to experiment as many times as you want, but without actually making any fatal mistake. As a nice side effect of having commits for your data, you get time travel. Time travel, which is a very fancy sci-fi name for a very mundane thing, is actually just the concept that it doesn't matter in which point you find yourself with your data, you can always restore the situation of your data to any point in time previously achieved. Which means, very easily, if I wake up Tuesday and my pipeline broke Monday night, I can go back in time to Monday night because that's where the problem actually was. None of this is in the S3 files, on Jeff Bezos hard disk type of things, okay? None of this abstraction is available. But this is the only way in which you're actually going to develop AI pipelines without destroying either the rest of your company or bankrupting it by your mistake. So GenAI is now S3, again, very, very large hard disk on the cloud, and Python, but they both have their own problems. So how do we go about building a good infrastructure for this? And the solution is to basically fix these problems in S3 and Python in a way that is actually conducive of GenAI pipelines. So we're going to add the tables to S3. So we're going to add some abstraction in a way that S3 doesn't look like an hard disk anymore. It's going to look more like a database. And then we're going to add to Python the ability to run functions in the cloud. Why in the cloud? Because if you never work in your computer in the first place, you can't have the "it works on my computer" bug, right? If everything works directly somewhere else, you don't have to move it to go to production. If you can experiment directly in somebody else's cloud, in somebody else's computer, you're already done when you need to go from prototype to the actual business value. So tables in S3, to have tables in S3, you need to add a couple of things. The most important one is open formats. There's many standards. We like Iceberg for several reasons, but it doesn't really matter. What open formats gives you, on top of the file system that S3 gives you, is two important things, which is the problems that we're trying to solve with building AI pipelines. One is giving you pushdowns. Pushdowns is a technical term, way less fancy than time travel. Okay? But pushdown just means that when you need a column from a dataset, you can just get that column. You don't need to read the entire dataset to just get a tiny column out of it. If you just need data for January because you're training your model on January, you don't need to get the entire year and then discard 11 months. You can literally just read January. Okay? And then, of course, you get versioning in the same sense that we discussed. So versioning, we call it two-dimensional because you both version things in time. You know, as time unfolds, you can always go back in previous versions, and you version things in branches. At any given point in time, you can have 3 different models, 4 different models, 10 different models, produce a new version of a data set, and evaluate that. And then, of course, for functions, we're going to put them in the cloud. So they still look like functions that you can write in your IDE, and you can kind of read and understand very quickly. But by putting them in the cloud, we achieve both simplicity. Again, there's no more two environments, my computer, Jeff computer. It's just Jeff computer now, so one less thing to worry about. And performance. Performance is, because a giant bottleneck when you actually work with data is bandwidth. Doesn't matter how clever you are with your Python tricks on your laptop, just the time it takes to download data from the cloud to your laptop kind of destroys all your productivity. By moving Python into the cloud, we're basically exploit like a 50x, 100x better bandwidth that there exists between S3 and virtual machines, and give you a much faster experience. So how does it look like when you actually try and build abstractions out of these two powerful ideas? Tables and object storage and functions in the cloud. So this is real syntax. It's not simplified. It doesn't really matter, the Bauplan specifics of it, but I kind of show you that you can take away a lot of the complexity that all of your data team is dealing with today and abstract them in something that you can understand even if you've never seen before. I probably bet that most people here have not seen a Bauplan syntax before, but I can always bet that you can understand immediately without me even explaining to you actually how this thing works. So we don't have containers. We have just packages, right? You see here, you declare pandas in a decorator, and that's as much as you need to do for that function to have pandas. We don't have data lake, Parquet, Iceberg, Hive. None of these concepts are needed to actually run a pipeline. What you need is a table. And a table is expressed here as the famous taxi dataset table that I'm sure you know, with columns and filters. Because again, we're able to support pushdowns both in columns and in rows. And then finally, functions. You don't have to know Kubernetes, you don't need to know Spark, you don't need to know Ray, you don't need to know any framework whatsoever. You can run just Python, the Python that you would run on your laptop, with the guarantee that it runs better and faster in the cloud. by actually simplifying down our stack to two things, S3 with tables and Python functions in the cloud, we actually achieve a massive simplification in the concept that you need to master to be productive. This is what you need to prototype, but this is also the same exact thing that you need to go in production with. The key aspect to moving, to crossing the chasm that many people described in this conference between, hey, it's a nice thing I built this weekend, to, hey, this actually produced value, mostly goes through simplifying your tooling. And this is as simple as it actually can get. What about the emerging concept? What about when we want to experiment, as we discussed? Again, it doesn't really matter. I mean, this is real. This is real, actually, Bobland code, but it doesn't really matter. The important thing is that if you've never seen this before, you can just read the comments and figure out what it does, okay? Again, there's no fancy terms like medallion architecture, right of the public. You don't need to know anything about data engineering to understand that you can run 3 different versions of models in your code just by running a for loop with a parameter. Because you may not know what a medallion architecture is, but for sure you know what a for loop is. And that's enough, that's as much as you need to know to actually run AI pipelines. If you do not believe that this is just what you need to know about AI pipelines, I challenge you to come and tell me what we need more. Because my intuition, my hunch, is that most people believe they need 25,000 AWS services or 400 notebooks or 1 million of other services because we're being sold for years by merchants of complexity that data is hard, that AI is hard, because these people make money by convincing you that you need a specialized team, dozens of professional services, and 1 million different tools to achieve what you need to achieve. For the most part, this is false. So what happens when you take all of these nice things and you ship it to a big company to try and get value out of it? Does it even work, or is it just Jacopo, rambling on the stage like he often does? So this is one of our customer, Mediaset. Mediaset is a very, very large company. It's one of the largest broadcasters on the planet. They have 20 million users, 10 billion views, and 76 petabytes of data every year across multiple digital properties. So this is not your, up-and-coming Series A startup in San Francisco with 100 users and nice VCs. This is one of the largest broadcasters on the planet, serving one of the largest markets, a G7 country, as far as digital content, okay? So this is what happened when they adopted good APIs on top of their S3 buckets, okay? So at day one, they were already able to run 100 pipelines on the platform. So let's picture this. A company with 4,000 employees that makes $4 billion a year migrated to a new data platform in an afternoon, so that within the same day, they were able to run this hundreds of times. But this is not, the highlight. The highlight is, of course, it's very easy to get started, but it's incredibly easier to adopt inside the organization. Why? Because the abstractions are so stupidly easy, the one that I show you, that it's very, very easy for everybody to pick it up. So 20 weeks into the job, we have thousands of runs between languages, between use cases, and with different personas. You start with a data science that needs to get unblocked on his data pipeline, and then, a few weeks later, DevOps people, data engineers, all are on board because they all know the few things that you need to know. What is a table? What is a function? That's kind of it. So, wrapping this up, branching and versioning are not optional for your AI journey. A lot of the issue that you're experimenting today of moving between prototype to productions are because you lack the fundamental abstraction around this concept. If you don't have branching and versioning, you'll always be afraid of trying stuff because you can never go back to the previous state, and because you cannot A/B test different models. In a world that moves so quickly with new models and new capabilities launched every day, the only way to make progress is to try out things safely, and this is what branching and versioning gives you. Second point, AI loves cloud, okay? AI loves cloud because a lot of your problems with doing data pipelines is, again, bandwidth. So running stuff in the cloud is way more efficient than building something locally. And the good news is that you probably, most likely, already have AI because you have a ChatGPT account or Gemini account, whatever, and you have cloud because you have an AWS account, an Azure account, whatever. So you already have the basic pieces in place, and that's what basically you need to start. What you're probably missing, if you're one of the people that complain about AI not making an impact, is good APIs. It's not 25,000 notebooks. It's not 27 AWS tools that you need to add to your tool chain. It's good freaking API. Good abstraction that everybody in your company can learn in an hour and then scale. Finally, you know who also is very good at understanding things that are simple, but is very bad with notebooks, UI, and point and click? You know who is very good at code nowadays? And the answer is AI. We built data platform for years with point and click and, and kind of like bulky abstractions because we thought that beginners would have a hard time having, a type system, having a lot of code, because we were thinking of simplifying the job of humans. And now that's a paradox. Now that we have AI is actually much better than humans at understanding code, or as good as humans, and is definitely much better with code than is with GUIs and notebooks. We didn't want to. We didn't build Bauplan for this, but it turns out that building an API-first data platform is the best thing you could possibly do in a world in which machines and humans work on the same code base, like literally work on the same code base. I added this on my flight here because this is like 2 days old. A member in the community autonomously find out about Bauplan and build an MCP server when he can chat using Claude with his entire data platform by using our APIs. In, I don't know, it's probably 15 lines of code. This would not have been possible if instead of, simple abstractions and simple APIs, we would have been dealing with, bulky platforms and a lot of point and click. If you want to know more, please reach out to me at any time, and thanks so much for coming here today. Ciao.